So hello again, physics friends. This is 1.3, the unit on velocity, and we're going to define speed and velocity in this unit. And I'm starting off with another motion diagram here, although this one looks a little bit different. If you take a look at this motion diagram, at time 0 the object is over here at a position of -10 meters. At 1 second it's moved over to a position of -9 meters. So it's traveled 1 meter in this second. But at time 2, it's traveled 2 meters over the next second from time 1 to time 2. So by looking at this motion map, we see the dots are getting spaced further and further apart. And as you might imagine, or as if you read in the book, this is showing that the object is getting faster, that it's traveling faster from time 4 to time 5 than it was between time 0 and time 1. So this is an object that's getting faster as time goes on. Now we're going to talk about the concept of fast and slow. We're going to use two terms to talk about fast and slow, both of which have words that you're familiar with. You're familiar with the concept, or at least the word speed and the word velocity, but we're going to give them formal definitions here. And they do have different definitions. Occasionally they will actually be the same number, but their meanings are different. So the first thing we're going to define is the concept of average speed. The definition of average speed has to do with the concept of distance. It's the total distance an object travels during a duration of time. So it's not really the distance, it's the ratio of the distance to the duration of time. The distance traveled divided by the total amount of time. And the unit for distance, we're going to use the meter as the standard unit, although there's lots of different units one could use, like a mile or a kilometer or an inch. But the meter is the standard unit. The second is the standard unit for time, although again there's lots of different units for time. There's hours and there's minutes, days, years. But for a lot of the motions that we're going to study, meters and seconds will do just fine. The symbol that we use for speed typically is the letter V. And V is the first letter of the word velocity, so that might not seem quite right. Why aren't we using S for speed? S is typically used for something else. Sometimes people just write out speed or average speed instead of even using a symbol for it. And again, the unit being the meter per second. Average velocity takes into account this concept of displacement, delta x being the change in position of an object. And so the definition of average velocity is delta x, the displacement of the object's position, divided by the duration of time again, which I'm just writing as delta t instead of delta time. The symbol that we typically use for average velocity is a V with an arrow, and typically we actually write AVG, or average, to signify that this is an average velocity. And the unit again is meters per second. And how are these quantities different? I'll try to show that in the next slide where we do some calculations. Here's yet another motion diagram. And this motion diagram is indeed more complex than the things we've studied before. Initially, the dots are spaced out so that the object's traveling 3 meters for every 1 second of time, and it's moving to the left. But then at time 3 seconds, the object stops. And we're showing that by drawing another dot above. Remember that this axis system is just showing us information about motion along a straight line, so left and right. Up and down, we're not getting any information. We're just studying the left and right motion. So by drawing a dot up, it doesn't mean it literally moved up. It means that it's still along the same position on this axis system. So from time 3 to time 4, the object hasn't moved. It's just been at rest. But then it starts moving again to the right, and moving a little bit slower than it was before. And by 8 seconds, it stops at this position of -5 meters. So what if we were to calculate the average speed for this motion? Remember again that this is the total distance traveled divided by the change in time. And if I look at the total distance traveled, remember the distance is a path length. So the distance it travels, starting here, and going over to, at 3 seconds, it's at -9 meters. So this total path length is 9 meters. It's 9 meters to the left, but distance doesn't have a direction, so we're just going to say it traveled a length of 9 meters. From 3 to 4 seconds, it didn't travel anywhere. It stayed put. Starting at 4 seconds to 8 seconds, the object traveled from -9 meters over to 5 meters. So it traveled this length. So that's 1, 2, 3, 4 more meters to the right, but again, there's no direction in distance. It's just the length that you traveled. From here to here spans 4 meters, from -9 to -5. And the total time that that took is 8 seconds. So if I add 9 plus 4, I get 13 meters. That all happened in 8 seconds. You'd think I'd be prepared with a calculator right away. And as you can tell, I'm scurrying for one. So 13 divided by 8 is around 1.625. So we'll go with about 1.6 meters per second. This is the average speed. The average velocity from 0 to 8 seconds, that's defined as displacement over the time period. Now, displacement usually gets this little arrow symbol above it as well, because it has a direction associated with it. So I'm going to start drawing that as well. The total displacement, if the object starts here at a position of 0 and ends here at a position of -5, you'll remember from a previous lesson that displacement is final position minus initial position. And these are getting little arrow hats just to show that they have directions. Your position is a directional quantity. So if I do that, the final position is -5 minus the initial position, which is 0, all over 8 seconds. -5 minus 0 is -5 divided by 8. So that ends up being negative 0.625, 0.6 is fine, meters per second. And you'll notice these numbers are different. One's negative, one's positive. Not every average velocity is going to be negative. It could very well be positive. But the thing here is this is providing some information. Remember, the object is to the left of where it started from, so the average velocity should be negative. The object is traveling at an average speed of 1.6 meters per second. So the meaning of this number is that the object is traveling a distance of 1.6 meters for every 1 second of motion. On average, not at any particular instant, it's traveling a little bit faster here and a little bit slower here. But over the course of 8 seconds, on average, it's 1.6 meters for every second. This number is a little bit more difficult to explain, and it's telling you something about how much it displaced over the time period, not really worrying about the path that it took to get there. Negative 0.6 meters per second means that the object could travel 0.6 meters per second to the left, and it will have gotten to this location in 8 seconds. The actual path is further off to the left, and then it kind of warps back around here. But if the object did start here and traveled at 0.6 meters per second to the left, it will have gotten to this spot at the same time that this motion gets to that same spot. And I can draw an arrow again to represent displacement. Again, showing that the displacement over this time period looks something like this. And you'll notice that it points to the left, beginning at the initial position and pointing to the final position. And really quick here at the last slide, what does a speed of 5 meters per second mean? In fact, how do you read any of these ratios where you have something with dissimilar units? We have meters in the numerator, we have seconds in the denominator. And for a speed of 5 meters per second, we read this from top to bottom. This number tells you how much distance the object traveled. Sometimes we say that this line, the division line, means per, like you'd say 5 meters per 1 second. But per really means for every. And then the bottom is telling you an amount of time change, 1 second of time change. So 5 meters per second is read as, at least the meaning is 5 meters of distance for every 1 second of time change. And that's all for lesson 1-3.